Yeah, welcome.
Now we have time for questions and dialogue. So if anyone from the audience wants to ask questions to our speaker, it's the time to do it.
I have one doubt. I understand that there was a word pattern.
Sorry?
Word pattern.
Pattern.
P-A?
Pattern.
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 Mold.
Pattern.
Mold. Yeah. In regard of cast
Mold.
crossings.
Molde crossing.
Yeah.
Okay.
Molde crossings especiais
Okay.
têm
It's not
custo.
pattern. Pattern.
Pattern.
Pattern.
P-A-T-T-E-R-N.
I read double F. Sorry.
T.
There was a mistake, there was a double F.
Ah, okay. Sorry, I will correct that before. Okay, sorry for that.
Because I know the word pattern, not pattern.
Ah, sorry for that. Yeah.
Okay, no.
No, that must be a
I
typing.
thought it was
Typing mistake, yeah.
Ah,
exactly.
It
It
was
was
a
a
typing mistake.
It's
Yeah.
a pattern, not pattern.
Yeah.
Okay.
Can you talk about the level of price between the normal device and a device like that? Of course, there are 28 different devices.
Yeah, you
But-
already have recognized that there are quite simple and quite complicating systems.
Of course.
I mean, we did not make any estimation or whatever, but as a rough idea, we would say that the worst case would be 50% in addition, roughly 50% in addition compared to a standard turnout. And actually that could easily be visualized as you have a third switch device, you have a third rail through, you have a second crossing, you need an additional check rail, so actually you take half of a turnout, put it one inside, so also from cost side it will be like that. It will be of course more complicated if movable crossings are coming into the game, but this is a completely different issue. But if we are dealing with rigid crossings, it will be like that in a range of 50% more for the most complicated
Yes.
types. The other ones will be actually less.
Excluding switch gears, I suppose.
Excluding switch equipment, yes.
The switch-
Yeah. So just the steelworks, the turnout, yeah.
Could put a question is about signaling. We can use track circuits or axle counters with that equipment. That's a difficult.
This is a difficult question.
I know.
Actually,
What's
here,
best of the best
Yeah.
solution? Track circuits or
this
X counters?
is actually not really the field where I'm coming from. I mean, what in regard of axle counters, what I know is actually the use of insulating joints. Doing the axle counting by use of insulating joints inside the turnout actually should not be a problem. We just need to find somewhere 6 meters where to include them between the switch device and the crossing area where they are usually placed. In regard of track circuits, actually I have to apologize. This answer is more on the signaling side, and I'm afraid I am not able to answer that.
That's very difficult. Very difficult.
Yeah.
I have a question here.
Yes.
If you can speak us about what experience do you have with these equipments?
We have recently a project in Brazil. A few pictures were from there, where we made, I think, 8 or 9 different types. So also the very complicated configurations. We supplied, I think, 25 to 30 dual gauge turnouts there. The design was done in our company in Zeltweg. The production took place in our local factory, and actually these turnouts, they are working since 5 years, satisfactory for the client, considering actually that there are two difficult things are coming together. One gauge is for suburban line, metro line, which has, I would say, less axle loads but high frequency, and the other line is for heavy haul, which is high axle loads, high impact but low speeds. So this is quite an interesting combination. And we have several projects in Switzerland between the Swiss Federal Railway and private lines. We are supplying, I mean, I would not say on regular basis, but every few years there are coming new configurations. And we also made already a few designs for ADIF, for the Spanish railways. These are done in our factory, which is close to Bilbao. This was handled directly by them. So there are some projects we already have experience. I mean, I also can tell you that dual gauge turnouts is not our daily business. I mean, this is a very complicated and complex thing, and usually railways try to avoid this topic and try to avoid installation like this. But yeah, some places or some areas we are not able to avoid it, and then they have to go for it. And I think we, up to now, we have quite a good success with our equipment in these railways.
I have a question also. Can you tell us, based on your experience, if there is tamping problems in this kind of devices?
I could not answer directly with yes or no, but I assume because you are thinking of having a dual gauge track, standard tracks. So actually these standard tracks also need to be damped somehow, either with movable damping fingers on the machine so that they are moving it further off the rail so that they fit beside the rails.
I make this question because you showed us
there
are a few space between the rails in the crossing section.
You are completely right, but I actually never asked this information. But out of this philosophy that a dual gauge track could be damped with a machine, also I assume most of the areas in the turnout also could be damped. I mean, you're 100% right that were rails coming together like that, hand damping or even no damping can be done. But I assume if a machine is available for open track, it can be used for most of the areas in a turnout also.
Will you please tell us about your experience in Spain in double gauge lines, including electrified lines?
Sorry, including?
Electrified lines, catenary. Including, but this is not the main question.
This is. I again have to apologize, but this is actually far out of our business. We are not dealing with overhead kind of catenaries.
Okay.
So I'm actually not able to answer on that.
But your experience on the dual turnouts in Spain, if there is problems just on the dual turnouts?
Yeah. No, there are no problems up to now.
Where have been the installations so far in Catalonia?
The installation site directly, I don't know, as we supply directly to ADIF, and we are not informed.
Catalonia.
Thomas, I have a question about limitations of the speed in the direct track and the diverted track,
Yeah.
especially on the direct track, which I think is more important. So
Yeah.
you have a station, you have a diverted track for trains that stop, but you want to maintain a nice speed for the trains that don't stop. How far can we go in terms of speed on these switches or turnouts for with organs? Probably depends on the type of turnout.
I mean, basically, we try for the main line direction.
Yes, that's
We try to set up the design that the line speed can be kept
Okay, without changing lines.
without changing line speed. Yeah, but
Including the switches that have obtuse crossings, the most complex, including
the movable ones.
Yes.
Yeah, no, the movable obtuse crossings speed is not an issue. The only issue is how we can design the rigid, the fixed crossings. If they're coming close to each other, then we have to make compromises on the flare lengths, on the wing rails. Because there is a certain formula which defines the length of the flare in relation to the speed. So if due to space restrictions the flare lengths cannot be maintained according to that formula, then the line speed have to be reduced. But actually our aim at stage of design is to keep and take care of the line speed of these turnouts. In the aviation it's anyway a completely different story.
Yes, yes, of course.
But I'm not able to answer generally yes on all dual gauge turnouts you can maintain line speed.
Okay,
So
if
then-
you have,
then it needs to be looked into detail. That is actually coming up at detailed design.
but I mean, if you have a reasonably high speed of say 220 or so, and
Sorry,
imagine that you have a design speed for the direct track
Yeah.
for say 220 kilometers per
Okay,
hour,
Yeah.
you can always design the turnouts in order that to allow that speed on the direct train in general cases, unless at least with movable crossings.
With movable
You
crossings,
can
yeah,
always do
but the question is if it's depending on the configuration. If two crossings are coming close to each other,
Mhm.
then it might be reduced. So this is actually a very good picture where two crossings are close to each other. For this, actually, it seems not to be a problem, or it would not be a problem
On that
in
one.
both directions to maintain the line speed.
Mhm.
But if this one is going closer to that, or the other way around, then there might be problems.
But
So-
overall, it's not that case. It's the case Iberian gauge with a standard gauge.
Yeah, yeah.
It's probably
Yeah, the configuration
more
will
difficult.
different because it's the two rails, they're closer to each other. Yeah. So this actually will only come up when we are doing the design, the detailed design work
Right.
for.
I read in your design that the flange rate could be a problem in certain cases.
The width of the flangeway.
Yes. I thought I read that the flange rate could be a problem.
No, I mean the flangeway.
Problem where?
Yeah, the flangeway actually need to be defined by considering all different wheel configurations.
Okay.
This might be in this context, but the flangeway actually is not a problem. We just at stage of design we have to set up a flangeway in the crossing and in the check rail area that all wheels have a safe passage.
Profiles.
Yes, exactly.
Thomas, let me try to make my ideas clear. The problem, you can have speed limitations if you have, if you don't have movable parts and you have two crossings very close to each other,
Mhm.
right? Is that
Yeah.
the situation in which you will be
This
forced to
might
have a
be the-
reduction of
yes, yes.
speed? Otherwise, you will be able to maintain the speed of
Otherwise,
the
we
main
are
track.
able to maintain the speed of the.
So it depends. So if we have a situation like this, in
Mhm.
this case, direct train, direct line, direct track, there is no reduction of speed. But if these two tracks, instead of turning to this side, they would turn to the other side, then they would be, the crossing with this rail would be closer,
Uh-huh,
then
yeah,
probably
yeah,
have a limitation of
yeah.
speed.
Mhm,
Okay?
yeah, yeah.
So you can do it for one side, and you cannot do it for the other
Yeah.
side, correct?
Yeah.
Okay.
That's why.
No, but now I understand. There is a criteria to understand whether the limitation or not, and the importance of design, as you said.
But we are talking only about the tracks. Maybe speed restrictions exist, I don't know, for signaling or for catering. I know it's not your,
Yeah, this.
your issue.
Regarding the turnouts, it's always a question of planning.
Yeah.
And avoid the complex
Yeah,
situations.
yeah.
And even if you cannot avoid, you could have movable crossings to
have
try to
movable.
solve the problem. You have to pay more, to be more expensive,
Yeah, yeah.
but it could be solved.
Mhm.
Okay.
But to have, for example, movable crossing here and here, this will not be possible.
Okay.
They require much more space. Yeah.
But you could do it in one of them.
We could do it at least for this one.
Okay,
for
so you
standard
do,
gauge.
instead of two closed
Yeah.
crossings, you'd have only one,
Yeah.
and you could improve the...
So actually, here it could be provided that on the standard gauge or the broad gauge, line speed could be kept.
Yes. Thank you. More questions?
So we can conclude that usually there was a kind of black history that this kind of switches always requested or speed restrictions. I think that it's not true. Dual gauge switches for themselves, I think they don't. We can conclude they are not the reason for strict speed restrictions. Is that correct?
You mean that by using dual gauge turnouts, the speed shall not be reduced?
Yes. The detractors of this kind of track usually argue that these kind of switches
Yeah.
were more expensive, they were more complex, more complicated, and they always imposes speed restrictions including in the main line, not in the deviation, in the straight alignment. And I think that is not correct, we can conclude.
No, that is not correct. Speed restrictions are only necessary if, as just discussed, if there is a special design or something like that required. But I mean, I know some locations in Austria also where since quite a long time these dual gauge turnouts are included or installed. Most of the installation sites I saw, where I saw these dual gauge turnouts, they are somewhere on a siding where a industrial narrow gauge track enters somewhere a station area. So in, I would say 99% of installation sites, these dual gauge turnouts, they are off the main track. So they are somewhere in a railway station area, on a siding, or where to enter a stabling yard, or wherever. So I think it's not an issue of speed restriction. And I'm not sure if you're really going to install them on the main line.
Here, the situation of having situations in which it would be important to install them on the main line probably would arise.
Yeah.
The problem is if we could avoid reduction of speed, and what I understood is if we don't think about it, we'll have restrictions of speed. If we think about it and we can avoid them.
Yeah.
There are solutions to avoid the reductions of speed, and that is what is important. I have another question. If you have movable parts on your crossing, the tendency for price increase, it is very high or it is still reasonable? Because what you said about 50% increase, we know that we have to pay more for these solutions because we have other advantages. And what we have is to compare costs and advantages for the economy by not interrupting traffic.
Yeah.
But
Basically,
I'm putting an extreme case. You don't. The only solution you can have to do not reduce speed is movable crossings. For would it increase the price by 10% more, by 100% more, by 200% more? Probably it's difficult to.
As a rough value, a movable point crossing, a single crossing, compared to a rigid crossing, will be only the steel works by 4 times.
4 times.
Yeah.
So the overall cost of the
Not the turnout, just the crossing.
Just a crossing.
in terms of the overall cost of the turnout, for instance, the case that you showed right now, where you had two crossings close to each other, say if you have a movable part in one of them, you could solve the problem. Imagine that case.
Yeah.
If you put a movable part on that crossing, to do not have speed restrictions, how much would it increase the cost?
But this is, you have to distinguish between the movable obtuse crossing, which is out of a, I would say, rather simple design, and the movable single crossing, which would replace a normal crossing. And this is much more complicated than the movable obtuse crossing. I can check. I guess I will have a photo of that. Just to have an idea. No, sorry, I don't have these pics with me. No.
Because you spoke about a 4 times increase, but it's just a part of the turnout. It's not.
Yeah.
Just at the crossing.
Just at the crossing.
How
Yeah.
much is the crossing in the turnout value? Maybe
I have a few old values in my mind, where the crossing was with. I would say it was only the crossings around 30,000 euros. The movable one.
So you have an increase of, say, 30,000 euros in something that costs initially 100,000 or 150. It's not that big in terms of.
No, it is possibly there is an increase of, I don't know, 20 or 22 or 23, but it's not only the crossing. You need ALT equipment, so switch machine locking detection. You need interlocking station, so this is going further. And in this case, as far as I know, the cost or the price of the movable point crossing is rather minor compared to the signaling, influences.
So at the end of the day, you can offset the double of the cost overall, eventually. Okay. So I understand it's very difficult, and sometimes we are asking questions that is not just like that to get the answer. And I apologize because sometimes questions result of not knowing the detail.
If I have some information, then I will share, and if I'm running out of my ideas, then I
no, because I think it's important for
of course,
our decision makers to have at least a feeling for what is at stake. Because at the end of the day, the cost of a line is not just the cost of the turnout.
Planning.
Of the rest.
Instant to planning before acting.
Yeah, because unfortunately our country is not so good at planning. We try to improvise too much. let's hope. We understand here that
But
if we want to save, we cannot do it by the usual methods of improvising on the last minute.
for this project, you see that the planning is, I think, then one of the most important things, a proper planning, which can be done and by using certain equipment or have a detailed look. Do we really need a deviation of the narrow gauge at this turnout? How often will there be a train passing, or could it be possibly go off the main line 200 meters in front of the turnout or behind the turnout? So I think a lot of things need to be thought of and considered and thought through actually, and
Yes.
then you can start simplifying all the turnout configurations.
I see. More questions?
Another question. In terms of the maintenance point of view, would you say that the costs of maintenance of these turnouts are about 50% more than
That
the...
I didn't say.
No, I'm asking, would you say that it would be around 50% more than a normal one? The more, the less?
No, I would say it will be more as you have more components to check, taking into consideration the most complex part. You have, usually you're going there to the switch, you have to grease the slide chairs. So you have one more switch where you have to grease the slide chairs. You have to check one more clamp block system which connects to the switch machine. You have to check two more check rates at the crossings. You have to check one more crossing. But I mean, this will be done anyway in one maintenance interval, yeah. But you will need more time, and you will need more maintenance effort if there is something to adjust, if there is something to build up well, or if there is something to grind. But it is, in my opinion, it's definitely not 50% more.
It's more than that.
No,
less,
much
much
more
less.
less.
Much less. Ah,
Less.
and you're talking about the turnouts only, right?
Yes.
Of course.
And the lifetime of these turnouts compared to the standard ones? You have experience?
Not
Okay.
really, but I mean, this is also depending on the traffic, on the load. Because it could happen that you have to replace one switch which is used for posts, which is used for narrow gauge and broad gauge, that of course will wear more because it is used of, let's say, double of the trains. So this will wear much faster than the other ones, where only a broad gauge train or only a narrow gauge train is going on. But having in view, let's say, a total value, sometimes we are able to provide, especially for crossings, we are providing values. This crossing will do, let's say, 200 megatons, mega cross tons, which can go over this crossing. This tonnage will be the same for all the components, independent if it's a standard turnout or it's a dual gauge turnout. So if your crossing lasts 200 million cross tons in a standard turnout, then the crossing will also last 200 million cross tons in a dual gauge turnout. The question is just how far this load is applied on this crossing.
Yes, but in our case, with our gauges so near one another, you have to use special crossings. Even if you have more traffic on one side of the turnout, you'll have, when you replace the crossing, you'll have to replace two crossings.
Yeah. I mean, it depends if you have. I think you might remember this picture with the cast crossing.
Yes.
There is no way. There is no way. Just.
But that's the one to avoid.
Yes, that's the one to avoid. But I'm not sure for this gauge configuration
If we can avoid too much.
if it can be avoided. I think you will end up in any case with one of these configurations.